Warning: this video is for entertainment purposes only. Please contact your local municipalities as well as a trade professional or general contractor before starting any do-it-yourself project. Hi, I'm Greg, and welcome to Greg's Do-It-Yourself Tech channel. If you're new to the channel, welcome. If you're a returning viewer, great to have you back. Today's episode is how to terminate or punch down Cat 5 and Cat 6 cable. As always, if you like the channel, please like, subscribe, and share so that other people can be aware of our channels, and you'll also be notified of future videos as they come out. So the first question is, why would we even want to use jacks or patch panels or a combination of both instead of just running a cable? Why not? In the last episode, we talked a little bit about terminating your own cables. So why not just put an end, run a cable, put an end on the other side, and just call it a day? Well, the reality is that's actually a pretty good way to do things a lot of the time. First off, since it only has two ends on it, it's actually a little less noisy than some other cables can be. So again, if that's what you want to do, watch the last episode again about how to crimp cables and learn how to put ends on both ends of a cable, buy some cable, or even just go to Amazon and get a long length cable and you're done. Okay. But in a lot of cases, jacks and patch panels come in handy. We're going to show you both of them in a minute and explain a little bit more about them. So reasons to use jacks and patch panels. Cleaner cable installations. First off, if you run your own cable, you might have a bunch of extra feet left over because if you cut it too short, then you're going to have a problem. So you have all this extra coil cable everywhere, and it just makes a mess. Also, seeing a bunch of wires coming out of a wall sometimes doesn't look the best. So having a nice clean jack and patch panels where all your wires come to a clean point really looks pretty cool, makes things look much neater. Next, it lets you use flexible patch cables that are different colors than the original cable. So in the wall, for example, if I was to have run blue cable, I could still put a patch panel, a wall plate in, and then I can choose different patch cables, which are these. Again, you can buy them from places like Amazon. But I can have different colors, regardless of whatever the color of the wire is in the wall. Now, the reason we talk about flexible cables, so this is the original cabling. Most of the cable you buy in spools that you want to run yourself are what they call solid core cable. Basically one long solid piece of cable. They don't tend to flex much. As you can see, it kind of springs itself back up. Patch cords are typically what they call stranded cable. So you can see how it just sags back down. It tends to easily coil up. You can kind of crumple it up into a ball without being a problem, where the other cable, if I tried, is going to kink. So basically, patch cords use stranded cable a lot of the time, and so they're more flexible. That helps them, especially in tight places if you want to bend them around things. Next, and the big reason in a lot of cases is that patch cords can easily be replaced if they're damaged, where the main cable, if it's damaged, should be replaced. What I mean by that is you have a cable that comes out of the wall. If it goes right over to your desk or whatever and it gets kinked, maybe somebody moved a desk and it broke the cable, or ripped out the insulation and stuff like that. Once you cut that cable, the problem is, cut it to clean it up. It's too short now to reach its destination. But if the cables are in the wall and they go to a wall plate with jacks, you can just simply replace the cord from that jack to the computer. You can also choose different lengths. So maybe you need a 10-foot cable. So you just take a 10-foot cable. Then later on you move your desk across the room and maybe you need a 15-foot cable. So you're just replacing that patch cord instead of the entire cable length. So these are all really good reasons that you would want to be using jacks and patch panels. And again, I'll show you both when we do the demonstration in just a little bit. So the jacks themselves are a special type of jack known as a Keystone Jack. And let's zoom in camera one, and I could show you a little better view of one of these. Oops. So basically, on the front is the jack where your cable would plug in, and the back is a special punch down spot where we actually terminate the cable, and we'll go a little further into it. But this is called a Keystone Jack, and we'll give a little bit more information about that in a second. And there are many different types of Keystone Jacks or different formats. For example, this particular one is meant for Cat 5 or Cat 6 cable. There are ones for fiber optics. There are ones for audio cables, video cables, HDMI. All sorts of different connectors are available. They all fit a standard format known as a Keystone Jack. So let's get into the definition, and then we'll get a little further into this. So Keystone Jack. Wikipedia's definition is a keystone module, as they are calling it, because again, some of these are jacks, some of these are other things. This particular one's a jack. But a keystone module is a standardized snap-in package for mounting a variety of low-voltage electrical jacks or optical connectors in a keystone wall plate, faceplate, surface mount box, or a patch panel. Keystone modules have a rectangular face of 14.5 millimeter wide by 16.0 millimeter high and are held in place with flexible tabs. This allows them to be snapped into a mounting plate with corresponding sized rectangular holes called ports. Most keystones are interchangeable and replaceable. This provides much flexibility in arranging and mounting many different types of electrical jacks in one plate or panel without requiring customized manufacturing. Some keystones use a pass-through type of connector where there is a jack on both the front face and the rear side. Others have a jack on the front and employ a different mechanism for hard wiring signal cables to the rear, such as mini 110 block, an insulation displacement connector, or a crimp or solder connector. Okay, sounds like a lot of words to take in, but basically, this type of jack, again, is a Keystone Jack. Now, what they said about pass-through is there are ones, for example, where it would have the jack on both sides. So inside the wall plate, you would run your patch cord into one side, and then sticking out the front would be another one, which is fine. But in a lot of cases, it's better to terminate them. It's a little cleaner, one less thing to go bad inside. And sometimes, for example, HDMI cables and other things require a bigger opening in the wall than just running a thin cable. If I just ran this straight cable through the back here, barely takes up any room. It's actually about a 1/4 inch drill bit, maybe 3/8 drill bit to get that cable through a wall. If I wanted to do the jack side, I need at least, that's probably about a 3/4 inch drill bit size maybe or so. So much bigger opening to get that through. And in the case of stuff like HDMI cables, even bigger. Okay, so basically there are different size plates. Well, let's talk about this first. First off, it says, not all jacks fit all wall plates. Example, 6-port or larger plates are sometimes require what they call high-density jacks. Okay, let me explain that one a little better. Let's use camera 2 for this example here. And let's zoom camera 2 in. So here's the jack. And in this particular case, what's nice about this one, let me see if I can focus it a little better. On the back side here, you have a big, wide open spot where you can basically punch all these down. Now, the advantage of that is it's easier to punch it down without getting all tangled up. The disadvantage is if I take a plate, so this is what they call a 6-port wall plate. And let me see if I can just zoom this out a little bit. So here, if I wanted to use 6 jacks in what they call a single gang outlet box. On the back side, the problem is when you look and I snap this in, it's too wide. So basically what happens is I can't fit 2 of these style jacks next to each other. I need what they call a high density jack. Now this is a high density jack, and I'm going to show you how to terminate both later on. The difference with this one is basically the punching area is straight from the back. So if you look at the front here, here's the front, here's the back. So it's straight in, where the other one, here's the front, and then this is the side, not the back. The back is flat like that. So basically what I meant by that is not all jacks fit all wall plates. If you think you're only using 1 or 2 in a jack, it really doesn't matter. Any Keystone jack will fit. However, if it's going to be a spot where you think you're going to get away with 4, maybe 6 jacks in one plate, you do need to understand the difference between these high density ones and the regular density plates. Now, while most jacks fit any brand wall plate, it is still recommended to use the same brand for both when possible. And what I mean by that is this, for example, is a jack from a company called ICC, which is a standard one we like to use. This is an ICC wall plate. It's good to try to use the same ones for both. Again, they're meant to all work together, but it's still a good idea to try just to use the same for consistency's sake. It'll fit a little better, and it might look a little better. So, again, another example I wanted to show you is, here's a jack from a company called Belkin. And let's zoom in on camera 2 here. And here's a jack from ICC. If you look carefully, especially at the side angle, the color blue is very different between these two brands. So if you were doing, for example, a 4-port plate and half of them are one, half the other, they're going to look horrible together. They're not going to blend. So it's usually a good idea to figure out which one you want to use. Basically, if I'm going to use one brand, try to stick through your installation that way. Even wall plate wise, again, the difference between one company's beige plate, or this one might be considered ivory, versus another is very, very different. And sometimes that can be a headache, especially if you're dealing with a company, for example, that already did electrical stuff. Let's say they used a company like Hubble or Leviton for their wall plates. If I come in with an ICC wall plate, my colors might not match. So these are all things to seriously consider when making those choices. If you don't care about color and you don't care with the jacks, and get the cheapest jacks, get the cheapest wall plates you can, that's fine. So the next thing is, when we look at the back of these jacks, and I'll use the regular density one because it'll probably look better on the zoom. When I come in here, you're going to see 2 different sets of colors on the back here, or 2 different sets of labeling back here. Okay, one starts with green and says A in the middle. The other one starts with orange and says B in the middle. So there's 2 different types of wiring classifications, and they both fall under the category of EIA 568. And I discussed this a little more in the last video about crimping cables. So again, as I mentioned in that video, when we're dealing with any of these things, typically you're going to want everything to be 568B. And in the next slide here, I'll show you real quick. By the way, EIA stands for Electronics Industry Alliance, if you were wondering. So basically, again, EIA 568B is on the bottom. Now, each jack is slightly different. Even though we showed you the color code for running crimped cables before, the reality is the jacks may have the wires in different locations and different orders, and that's perfectly okay, because internally in this jack, it moves everything into the right position. So for example, you see here position 3 and position 4 are white, blue, followed by blue. Now, reality is that is pin number 5 and 4 in reverse order there, and they skip over 3 and 6, which are actually over to the other side. But basically, internally in the wiring, they flip those wires around to give it the same look as we did before. So Again, looking at the code we showed before, which is white orange to orange, white green, followed by blue stripe, followed by solid green, followed by white brown, followed by solid brown. Internally in this jack, it will actually move those in that position order. So it doesn't really matter where they are. The key there is to recognize we're going to follow the color code that shows B on it. Okay, let's get on to the fun part here. Jack termination and patch panel termination demonstrations. So first thing we're going to do here is I'm going to cut off a little chunk of wire. And again, I'm going to demonstrate with this stuff here using the tools I'd prefer to use, which again is something like this stripper over here. And let's zoom in a little bit so we can show you what's going on here. Now, the one other thing I'd like to talk about actually before we get over here, kind of bouncing around, sorry about that, is on these jacks here. Basically, the tool we use to, let's talk about the tools first. So the tool normally used for these type of jacks is, I'm going to put this over here. So the tool we use for these type of jacks is called a punch tool, which basically looks like this here. It has a spring on it. Let me zoom in a little bit. There we go. So basically, it has a spring built inside that causes it to punch. That's why we call it a punch down. Let's focus it in a little better. There we go. On the blade, on what they call the blade on the top, a lot of these blades here have a cut edge. And let me see if I can show it to you on this one. Let's zoom it really far in. It's a little hard to see, but right here is the word cut. So what that means is that that side there is the cutting blade. The other side here is a flat blade. So we always have to take an idea where the cut side is. Now let's take this out again. And I'll explain again a little bit about the differences in the tools. First off, don't try to terminate one of these without a punch tool. Some people try to use screwdrivers. It doesn't work. They also sometimes like to use the edge of a tool like this. So this is one of my favorite stripping tools. Built into this is the ability to push that wire in. The problem with doing that is it doesn't cut the wire at the same time. Try to focus that in a little better. So in the back of one of these punch blocks, we can get this to fit in here. However, it doesn't do the full job. So let me start stripping out a cable, and I can explain that a little further. Now, some of you who've used these tools before might be looking over at me and saying, wait a second, what's up with that punch tool you use? Most of the time people are used to tools like this one here, which are square, or rectangular, I should say. The problem is, someone like myself, who does a lot of this work, over time, holding it like this, it's kind of weird for your hand. Your hand's used to curving. Think of a baseball bat as you're holding it. This is square. What I find over time is it does cramp up your hand. So I found this tool, and it's going to be on our website. We'll show you links to get it. But from a company called Klein Tools. And this one's circular. Now, I bought this years ago. At first, I thought it was a little odd. Hey, looks different. Let's give it a try. But the reality is when you're holding it, it holds much more like things you're used to, which is more circular. Your hand contours better. So that's why I like this particular one better. If you're only doing a few of these once in a while, it doesn't really matter which way you go. But I highly recommend a punch tool versus trying to just push it in. Okay. So let's get into this a little bit here. Just grab an end of a cable. So again, I like these type of strippers right here. And I'm going to go in 1 or 2 clicks till it feels like it's about right. And again, just like I showed in the last video about crimping cable, I'm going to twist it a little bit. And I'm going to push down. And it will break free. Then I can just twist and pull off. And the reason I like that is because, again, I don't have to worry about stripping cable. One of these guys, you can buy these for like $1, $2 on Amazon. Totally worth the money. Now, the one that some people go back and forth on is these. I love these kind of strippers. Excuse me, scissors, electrical scissors, because they can cut the ripcord real simple. So let's look at the first jack we're going to do here, and I'm going to try to zoom in as close as we can, right about there. See how close we can get it. Perfect. Okay. Zoom it in, right? There we go. Okay. And I am going to zoom in a little bit here so you can see for me what I'm doing here a little bit too. There we go. Okay. Perfect. Okay. So first, let me show you a trick that is going to save you a ton of time. What most people think they have to do is take the wires like this and unravel them. The reality is you don't. Let me focus that a little better. Okay. So first off, here's a couple things to understand. This outer jacket is insulation. It helps protect the cable from noise from other cables around it and crosstalk. The closer you can get that insulation to where you're terminating it on the jack, the better, because that's less stuff to get exposed to outside noise. Now, when your cables are twisted together, as we call them twisted pair, the more the twists are there, the better. The further you get away from twists, like I unravel this cable here, now this particular pair is exposed because it's not twisting and canceling out noise around it. So it makes it more vulnerable for noise. So the less we unravel and twist, so like basically if I was going to put this in the jack here, I don't want to have a bunch of cable behind it. You see how, if you look here, I have all that distance. All that distance helps cause more noise issues. So let's focus it in again. There we go. So first, what I like to do, especially on a jack like this that has long, like a basically long punching area, is basically if you grab with your finger or some other device and you twist it out, you can actually untwist the pairs close to the connector itself. So I'll show you here. Like, watch this. And I like to do the middle pairs first. So you can see I've got the blue in position. And all I'm doing is sticking it in there. I'm not actually terminating it yet. Now, next one here. Again, just take something like my thumb. And I'm going to pull. And that opens it up without me having to deal with unraveling all that cable. Last one here is brown on the right. And the final one is the one I unraveled before. And what you see is now I'm really not that far away from where the wire ends and where the jack begins. Focus that a little better for you. Now is when we use our tool, which is again the punch tool, to terminate this. We're going to punch it down, and what we're going to basically do is we're going to force these wires into these grooves. You don't have to pre-strip the wire. That's the beauty of it. It will strip itself, and with the right cutting tool, we'll actually punch down and cut at the same time. Now, here's the catch with these, and let me just save my positions on these cameras for a second. I'll make you number 6. Okay, so let's zoom out for a second. So here's the thing with these. I can straight punch this cable right down onto a surface, and this will be the tool I'm going to use. The problem is if I punch down, let's say I have the wire hanging out of a wall. If I punch down onto the wall, this tool is basically going to push this thing right onto the wall and make a dent. So here I have this silicone mat here. If I punch down, I'll actually probably dent the mat. So there are 2 ways to do this. First one I like to always demonstrate is the way I do it, and second is the alternative. The way I like to do it is by a device like this, which is a puck. This particular one comes from a company called Cable Matters, which I think is an awesome company for tools like this. And basically what you do with their tool here is you're going to put the jack. Typically you would do this before you get started, but I just wanted to show you the other stuff first. And basically it's going to hold the jack in position before we do the next thing. So let's go back to the other camera. So now as you can see, let me focus that camera a little better. There we go. It's holding the wire in position, or I can hold it in my hand like this. Either which way, it does a great job of keeping this thing from flying. Because if you do this wrong, it will absolutely break the jack and break the cable, and sometimes it'll punch a little hole in your hand, which hurts a lot. I've done it a few times myself. So looking at the tool, again, there is a cut bit on the one side. You got to figure out which is the right side. Because what I'm doing here is I'm cutting away. Basically, I'm cutting away from where the cable comes from in the opposite direction. So let me see if I can show you here, especially on camera 1. Let me zoom this in a little better. Okay. Actually, I'll zoom it out so you can see my hand in motion too. There we go. Okay. So again, basically I'm going to press straight down, and you hear that punch noise, and I'm going to move on to the next one. 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 Now, if you're using an old tool like mine, it is possible that it doesn't cut the wire all the way through. It does terminate, and it did cut the wire. The whole thing is it's not going to show you 100% here. Give me one sec here. Let me just zoom that in a little better focus. There we go. So even though those things are terminated, they may not always come flying off. A brand new bit, almost guarantee you they will. Now what I'm going to do here is basically I'm just going to rock them back and forth a little bit, and they will snap off. As you can see here, just twist, twist, twist. If you pull up and the thing breaks free, I mean basically pulls out again with the original wire intact, then you didn't terminate right. But if I do it this way and I can just twist it and it comes free, by just twisting it back and forth a little bit, then you know you did it okay. So again, if you have a brand new punch tool, chances are those pieces are going to go flying, and that's great. If it's a little older and your bit's a little more dull, it won't cut all the way through, but it did cut it because, again, you could see once I wiggle them a little bit, they've already broken, so they were already nicked but not fully cut through. Now I can pop this jack out of here. And this particular tool, sometimes they want you to punch from the backside. So basically just stick something back here like a screwdriver. And it will basically free the jack out of it. There it goes. And there you go. So basically we have a connector. Now, typically with these, they have also a strain relief. Let me focus that a little bit for you again. There we go. And basically the strain relief snaps over the top like that. So basically, now that they're in position, they're not going anywhere. Even if you tug on this, it's not going anywhere. Okay, so there you have a jack. So again, this is the long jack. I want to show you another quick example with a short jack, or high density jack, as we should call it. So that's one. And by the way, let me just show you this here. So here's my wall plate. And basically on these jacks is typically wording on the back of them that show you the upside. Let me see if I can show it to you back here. So we look at the plate. Let's focus it in. There it goes. So in the upper hand corner is up. On the jacks themselves, there's typically a spot that shows up as well. This one's probably going to be a little hard to see, so let's just go for how it connects in. You press the bottom side down, snap in, and there you go. Now you have a wall plate. Okay. So next thing is let's do a second jack here, and this is going to be what they call a high density jack. So what's cool about this particular tool is it even has another spot here. It had the spot in the middle where the jack that I just showed you can go, but if you're going to do ones where the connection's on the opposite side, you basically just stick the jack in here, get it in right, and then you can still hold it the same way, and basically you'll just punch straight down. Zoom in here and show you the top. Okay, but again, since I like to show alternates as well, what we're going to do now is I'll show you what happens if we use something else. Maybe you don't want to spend $7, $8 on this tool. Maybe you just want to use something like a piece of wood block that you have lying around. So again, let's do some alternatives. So again, let's use a different stripper this time because, again, I like to show little alternatives here. Let's say you just have one of these style strippers. So like we showed in the last video, I'm going to take a chunk out of it, pull my ripcord back, and that's going to expose more cable. Now I can cut here. Again, it works better with the electrical scissors, so that's the way I would prefer it. But just to show you another example, I can cut this off, and now I have all this cable. But the thing about this cable here is it doesn't really matter because, again, I'm going to show you that neat little trick we were just talking about. And we are going to unravel without having to go through all that untangling. So let's do this here. Should be about right. See, punch tool. Maybe out a little bit up. Okay, perfect. Switch to camera 2 and focus. Okay, so this one's going to be a little harder to see, but basically, again, it has the same type of idea. And what I'm going to see is on the top here, so brown is in the upper left-hand corner, upper right-hand corner, is again, if I bring it in as close as I can, and then just unravel once, you're going to see that I can just drop that in there. Boom. And actually, wait, this one's orange, sorry. So let's do it this way. So brown's over here. Then orange is over here. Then on the other side, we have blue on this side. And flip green over. Green's going to be on the other end. So when you look at that now, see how the wires are nice and neat. I didn't have to unravel any of that because I basically just grabbed it here and twisted until it came free. Now, this one's a little more complicated because what we have to do is, again, you have to know which side's the cutting side, which is currently right here. Let me show you. And you have to spin it around. So first, we're going to cut this side. And again, what you're doing is you're going to take your hand and hold it as tight as you can. If you don't and you slip like that, you could actually break the jack and sometimes punch your finger down, and that hurts a lot. So hold it nice and steady, and you're going to punch straight down, not to the angle, not to an angle. It's got to be straight on in. Again, my tool's older, so I spin it a little bit. If I can go like that and pull it and break away, I know it's good. If I pull up and the wire comes up on the other side with it, then I know it didn't punch right. Now the trick is going to the other side. I have to take the tool and spin it. So now the blade is facing this way. If I don't do that and I punch down exactly the same way, I'm going to punch the cable on this side and cut it, and it will break away. And actually, it will not make a contact because I broke the wrong side. So basically, when you go from this side of the jack, I'm going to flip it, the tool, the other direction. Now, the word cut is on the opposite side. Okay, now punch down, punch down, punch down, punch down. Again, holding it, spin a little bit, twist, boom, gone. This one has a little different strain relief. We're going to stick it over here. It actually rides up the cable, and you put the cable right smack in the center, and then this clips over there, and there you have it, a very nice clean jack. And as you can see, when we did that, the wire, again, the insulation is right up to the edge, as close as we can. The twists pairs are right up to the edge, and you want to terminate as close to the jack as possible. So here is, again, another example of a jack. So let's cut this one out. And let's take out camera 2 a little bit. And here, for example, let's take the 6-port plate. And if you look at this plate, again, let's zoom in a little bit. And you're going to see at the tippy top, there's the word up. So on this jack here, on the top of the jack is the word up to. You really probably can't see it, but it actually says the word up right there. Snap it in, and there you go. Now you have a jack plate there. And just to show you with the demonstration before, here's that jack from Belkin. And let's put that in the one next to it. So from this angle, they look similar. But if you zoom in close, and you got the light just right, I'm not sure we're going to see it right. Let's see if I can focus it a little better. If you're good at color, you'll see that this blue here is a different shade than this blue here. Probably easier to see it on the back side here. See the difference in the glossy. So again, that's the difference between using two different brands on the same wall plate, is that it will look slightly different. Okay, so this is the first part here. We've gotten our jacks done. So this is typically what you would see at the workstation side. Wires are coming down the wall or whatever. They go to a outlet box that the wires come out of. You're going to terminate these plates here. And then you would put a patch cord in, like this. And then this patch cord would typically run to your computer. Great. Now the other side is a patch panel, which we mentioned earlier. So the difference is this is a patch panel. And probably, let's see the best way to show it to you. Probably not the best lighting to show it to you on that one. So let's show it to you from the upper camera on camera 2. Okay, this is what they call a 48 port patch panel. So there's 48 jacks over here. And on the back side is what they call a 66 block. Excuse me, a 110 block, my apologies. And each one of these jacks has one of these. So basically each wire goes over here. Now, a couple things. First, some of them, like this one, come with a thing called wire management. So I can clip this piece on here. And what happens is your wires would then zip tie onto this wire, this piece here, before they go to the jack. So they can come straight in and down. But a lot of times we use these in racks. And the wires may be in the rack coming in from one side and going across the whole way. So when they do that, where basically all the wires come in from the left or the right, and they zigzag across basically come across each other. So the first wire goes here, the next wire jumps over it to the next one. And those style typically have little hooks here for putting zip ties. So basically you do your first set of jacks, let's say like here on this side, here's our numbers. So we do jack 1 through 3, like all 6 of the first ones. Then we're going to zip tie this batch, and then here comes the next batch, and the next batch, and the next batch, and we go across. That's great. The only problem is same rule applies. You gotta keep the insulation in. And let me show you again. Let's zoom in a little bit more on camera 2. And I'm going to show you the mistake people make with these things all the time. So, here's jack number 1. It's all the way over here. Now, the mistake people tend to make with this thing, let me take camera 1 down a little bit. And I've seen people do this and it looks beautiful, is they take the wire and they strip it way before they reach the jack. So I've seen actual job sites, and let me do that one again, it wasn't all the way in. There we go. Where basically, let's say this was the jack they wanted. They would strip the wires back here, so you see nothing but the actual pairs from multiple cables going to each one of these. And all your wires are here, and you just see a basic rainbow going across here. Looks pretty as anything, and it's horribly wrong to do that. The reason it's horribly wrong is because it's not up to code. All those wires are crisscrossing and talking to each other and causing all sorts of interference. So in this particular jack here, what you're seeing, let me just move the camera over a little bit closer. There we go. And let me make sure you have enough room to see my whole tool here. Going up. Okay. So basically, what you want to do is you want to bring your wire in like this. Now, if you look at the colors here, you have, again, this particular one is already set for 568B, and they say flip it for A. So this particular one's great because you don't have to see the other colors. The other cool thing is it's got a little blue indicator here. Now, the blue pair doesn't start on one side or the, like on the right of it. Basically, the blue little divot here is the middle of the blue pair. So the one wire is on this side of it, the other wire is on the other side. It makes it really easy. So what I like to do typically is I start in the center. So we're going to start with the orange pair. So it's going to start white and then solid orange. I'm going to bring the wire all the way up here, and I'm going to bring it into where it needs to go. Again, we're not terminating it yet. Then next to that is the green. And the reason I like to do this first is because it sets up the wire really well for everything to be central. So you see how I got those two there. If I start with the blue or the brown, the wire tends to go to the pulls to one side or the other. So if I do the center pairs first, it actually keeps the wire nice and central. And I'm going to show you as we do this. Okay, get that one in. And then finally the blue pair. So again, just by twisting it a little bit, you actually don't have to unravel all this. And that saves you a ton of time. Now, I'll use a different punch tool just to show you for a second. This one, the spring's busted. But you can see on the top of it, just to show you, is the word cut. Some tools are really neat like this, where they show you in big words where the cut side is. I don't think mine does too. It's just a little harder to see it. It's actually right there. Let me see if I can focus. There it is. So if you look really carefully, right there is the word cut. Just a little hard to see. Where, like I said, the other tool, it's quite obvious where the word cut is on this one. Focus it again. There you go. But anyway, I'm not going to use this tool. I just wanted to show you what it looks like. Let's go back to the regular tool here and zoom it out a little bit and focus. Right about there. There we go. So again, I know which side the word cut is. I'm used to this tool. I can also see the word cut on the top here or that little yellow band. Doesn't matter the order you punch it in. I just like to put the wires in that other order because it helps keep them in place. So I'm going to punch. Now that one didn't go all the way in. I could feel it, so I'm going to hit it again. Okay. Now that they're all in, again, if they come right off, great. If they don't, a couple twists back and forth will tell you pretty quickly if they're right. See? And then that last one there should just pop. See? Nice and clean. Now, because I used it in the center, and you can see how close the wire is to the jacket, I can just go like that. And now I have a very, very clean connection. Let's demonstrate one more on the same punch block, just to show you here. I'm just cutting this here because I'm going to use the same wire to simulate another wire. So back to the usual way I do things. I'm going to use my tools that I prefer. Spin twist that. Pull that off. Take my scissor, cut the ripcord, and we're going to go to the bottom side. So again, we're going to do exactly the same thing. I'm going to start with the brown pair. Excuse me, I'm going to start with the orange pair, I should say. Bring it in nice and tight. Then I'm going to go for the green. And again, just get your finger or even the panel itself is a great way to hold that wire. Just twist around it and it will break the twisted pair enough that you can get the wire in the position. And then finally we do the outer one. So I did the brown. You could do blue or brown first, doesn't really matter. Get that in position. Now here's the catch. Again, with this tool, you got to realize you had the blade upward for this one. So now I have to flip the blade around. So now the cut side should be facing towards me. Before it was facing away. That's one of the big tricks you're going to have to spend some time getting used to, is whether it's towards you or away for the particular thing you're cutting. So again. Spin them around a little bit. Again, if your tool is new, hey, I have punched thousands of blocks with these tools. So if you twist it a few times and it breaks free, you know you got it. If you pull up too fast and it actually the whole cable comes up, then you know you did it wrong, and you could probably punch it down one more time. You don't want to reuse these blocks though later on. So if you've punched this down and it's good, you leave it alone. Don't take out cables and put new cables in those spots, because what happens is when that tool punches down, it basically is a wire here, like we use this here. So it's a wire that goes between these two little pieces of metal, like that. As you push it in there, it strips it out, but it also, the metal itself, lifts a little bit. So if it expands and you pull that out and it stays like that, the next cable you stick in there is not going to hold properly. So you don't reuse punch panels, or patch panels, I should say, or jacks. It's better to throw out a jack and put a new jack on if you have to change something up than to reuse them. Okay, so let's zoom this out a little bit. So now with the patch panel, basically, let's pretend, for example, we had the two jacks here, and let me cut the end off this wire here. Pretend this is all hidden behind the scenes. And as you saw, two nice wires coming in here, and then you would just continue your wires all the way across. You know, assuming you have a rack that swings open. I'm coming in from here, it swings, or your wires come in from one side. So, again, why do we use patch panels? Because we talked about the jacks, that makes sense. Well, first off, let's say you have a building where you have 5 desks. You might want to run 2 wires for each desk. So, wire 1 is the first wire for a desk, wire 2 is the secondary wire. Why? Because maybe you want to use phones later, printers, maybe a just-in-case wire. Well, if you're not using all the wires, you don't need to plug all those devices. Like basically all those jacks don't need to be live. In fact, it's better that they're not. So if you're only using jacks 1, 3, 5, 7, you should only plug cables into 1, 3, 5, 7 here, and then from here, a cable goes to your switch or your router or whatever other device on the other side. Because if you leave a wire plugged in and it's not connected to something on the other side, it becomes an antenna, and that can introduce noise onto your hubs and your routers, and you don't want to do that. So again, basically the same thing here. On the workstation side, you'd have a jack like this coming out of the wall. You're going to plug your patch cord in. Other end goes to your computer. On the switch side, you're going to have, or your data equipment side, you're going to plug in. Let's say it's jack 1. And this side might go to your hub. Hopefully that makes sense. Now, some people take a 6-port plate like this, and maybe you only have 6 jacks in your entire building, and you don't want to spend a lot of money on a patch panel like this. You could actually have individual jacks to your 6 locations, go back to your data room, and go to a plate like this that has 6 jacks. And that's all you need, because you don't need something fancy like this. I mean, they do make patch panels like this in sizes like 12 ports, 24, 48, 24 and 48 ports. And then you can add big racks of equipment. So here's a 48, then another 48, another 48, another 48, like that for big data centers. So those are different ways to do things. Another thing, too, is they also make patch panels where the patch panel itself will take these type of Keystone Jacks. So basically, the entire panel is just a bunch of openings, and you would take a Keystone Jack like we terminated before. Let me pop this one out for a second. By the way, if you ever need to pop one of these back out of the back of a plate, typically you go to the top side, which again you'll see the word up above it, and you stick a tool like a screwdriver, a flathead screwdriver in, and press down, and it will come out. So basically, there are patch panels with just a bunch of openings, and you would take your Keystone Jacks like this and snap them into here. The advantage of those is you could change things. Like maybe you want a couple network jacks and you want some audio jacks or other things in your patch panel. Or, heaven forbid, one of these jacks goes bad, you can pop it out and replace it with another jack. Where With a panel like this, we have to put a little piece of tape or something over it and mark, hey, don't use position 1 anymore. Something bad happened to it. So basically, I hope that explained things well to you for terminating cables. We showed you a few different tools that we didn't show in the last video, which again are a unit like this, or again you could use a wood block. But frankly, for under $10, one of these is really, really good, especially if you're going to do a bunch of these jacks. Again, don't recommend punching tool, using a punch tool to punch down on a wall itself. It will dent sheetrock. Usually what happens is the little prongs on the back of the jack as you're punching down literally just stamp the wall. So you either, use some type of protective mechanism against the wall. Free wood blocks sitting around, or again, I love these things because you can just hold it in your hand and literally just punch like right here. Again, on the website, gregsdiytech.com, go to the tools page, and we'll have all these tools and links to Amazon or other places to pick up those tools. Great way to get the tools you want for this kind of work. Hope this video has helped you a lot. And as always, if you enjoyed the video, if this is helping you, please like, subscribe, share the video with your friends. Maybe you know somebody that wants to do this type of project and is a little uncertain how to begin. Please, send share the link to the video and show them that, some neat tricks we showed you how to help. I think one of the coolest tricks is, again, that neat little thing where we can unravel the cable in the middle instead of having to unwind all the pairs. Someone taught me that ages ago, and it changed everything for me. I save thousands and thousands of hours not spinning out, like the untwisting the pairs. So again, if this stuff is helpful to you, if this is a neat trick, please like and subscribe and share our videos so we can continue to make more. Check out our website. Again, shows all the video links besides our channel. And again, that is www.gregsdiytech.com. If you have suggestions, if you have ideas for another video, something you'd like to see technology-wise, please put it in the comments below. We'd love to hear from you. We'd love to know what you're thinking. Again, I hope this was a lot of help for you, and please continue to tune in. We have a lot of great topics coming up. Thanks again, and we hope you have a great day.